Yes, it started. Then I have shared my screen. $140. Maybe let's just wait for a minute. Okay, this 140 is getting a bit somewhat constant. Anyway, let us start. Okay, so you can view my screen, right?
Yes, sir.
Yes, sir.
Okay, good. Okay, so I will keep this chat window open. So if needed, you can write things there. A little bit there. Okay. Okay, so today we will discuss about, talk about expressions and assignments. Recall that you have the basic units, basic data types to store pieces of information like integers, real numbers, even characters. Okay. So there are two ways you can assign values to these so-called variables. One is during initialization, you specify some constant values. Another possibility that we have seen, read from the user. Okay, so the third thing that we will see today, how to give values to your variables, that is using assignments. Okay, so an assignment operation is of this form. I write it this way. I will explain things like this. Left value is equal to R value semicolon. Okay, so this is not the equality operator. Okay, it is what is called the assignment operator. In this side, what is called a left value of an assignment, it should be a variable. Okay, and this is an expression involving several things. Expression may involve constants. They may involve other variables. And these constants and variables are connected by a set of operators. Okay, so I will give you clear examples. Operators may be classified for the moment into three categories. Arithmetic operators. Then you have logical operators, and finally you have something called bitwise operators. So today I will explain this and this. Bitwise operators are a little bit complicated, so we will leave it for future if time permits. Okay, so to start with, I give you some examples. Okay. This is just some examples. So you say something like assign to x the value of y plus z by 6. Okay. So I assume, okay, in C actually, you cannot use a variable either as an L value or in the R value in an expression without declaring it previously. So I assume that x, y, and z are defined, declared somewhere earlier. Also, it is assumed for the sake of, I would say, sense, that y and z have some specific values. They may be initialized during declaration. They may be, for example, input or scanned from user inputs, or they may have been assigned values in a previous assignment operation. Okay. So these are some examples. Maybe something like A equal to B plus or B star 2. Maybe C equal to, I will explain what this means, double equal to. These are all arithmetic operations. Addition, subtraction is not written here. Multiplication, division, things like that. And this is what is called an assignment operation. So I will one by one clearly elaborate different types of expressions. Okay, so this is actually a logical comparison. So it's a logical operator, whereas this plus, this division, this star, these are all arithmetic operators. Okay, and here are some non-examples. Let's say x plus 2 equal to 5. This is not allowed because this is not a valid L value. So of course, by looking at this equation, you can see that essentially you want to assign 3 to x, 5 minus 2, but this is not allowed in I would say, C's syntax, because the C compiler will not solve equations, linear or non-linear, univariate or multivariate for you. Okay. If you specify it this way, it essentially means you solve for x. Okay, so equation solving is not allowed by default by the compiler. Equation solving, okay, is not the compiler's job. Okay, so what happens when you have something like this, a variable equal to expression? So everything involved in this expression, like y, z, 6, and all these values, they are fetched from memory. Okay, and then these operations are applied on them, and whatever is the final result, that value will go to this variable. Okay, therefore, when I say something like this, z equal to z minus 2, we have already seen some such example in an animation. Okay, but it says that bring the value stored in z, subtract 2 from it, and assign whatever that value is to the variable z, which turns out to be the same as the input variable z. Okay. So this kind of things are allowed, although it does not make mathematical sense. It cannot be equal to z minus 2. Okay. So this is not equality. Once again, let me highlight. This is an assignment operation. Okay. So this is assignment operator. Okay. So I hope this is I think fairly straightforward. So let us now look at arithmetic operations. Or operators. This is plus, simple addition, minus, subtraction. Now multiplication is not denoted by something like a product sign, because if you look at your keyboard, you will not see anything called a multiplication sign. Okay. Of course, as somebody mentioned yesterday, there is a Unicode character for it, but C does not support Unicode. So you have to use this star. Star means multiplication. Forward slash means
The start for multiplication is for the fact that C does not use Unicode. Then Java uses Unicode. That still we have to use start there also.
yeah, it's actually it actually depends on how your language is defined. Actually, it's a very dangerous thing to, I would say, use an Unicode character for writing your programs. Because, for example, I do not know an easy way to print that multiplication sign. Okay, so my keyboard does not have any nice support for it. So how do I print it? Okay.
Yes, sir. Okay.
That's the reason these operators or whatever symbols are used for writing your codes, be it in Java or C or C++ or Python. These are all restricted to standard 7-bit ASCII. Okay, whatever you can type, whatever not only you, every person on this Earth's surface can print using a valid keyboard, using any standard keyboard. Okay, so division actually means two things. If the operators are integers, long integers, even characters are also integers, this division essentially means quotient, Euclidean division quotient.
And sir, what is the meaning of Unicode?
If you do not know, forget it. So ASCII is just an 8-bit font format. Unicode is a 16-bit font format. This is widely used nowadays, but not during programming because there is no inherently easy facility to supply Unicode characters to your editor. Okay, don't worry about this. Anyway, and if these are floating point variables like float or double, this just means division. Okay, so I highlight this difference. So if you have two integers 5 by 2, this evaluates to not 2.5 but 2. On the other hand, if you divide 5.0 by 2.0, this is now a floating point division. This will evaluate to 2.5. Okay. So you be careful. Okay. So on which operator you are applying this division operator, the exact result will depend upon that. Okay. So I will give you an example to illustrate this. Then you have something. This is also a kind of division, but this is basically remainder, or you may call it modulus. Now the idea is that For floating point numbers, modulus makes no sense. So this modulus operator is applicable only to integers. And when you say 5% to, what is the remainder? This is 1. So this is 1. Okay. So these are the standard arithmetic operations. Okay. And depending upon the arguments, here I have used two constant arguments 5 and 2. Here also I have used two constant arguments 5.0 and 2.0. And based upon that, the result is 2 or 2.5. Whereas this percent operator applies only to integer operands. And of course, you know, as in mathematics, it is a crime to divide by 0. So this second operator cannot be 0. This second operator cannot be 0. This second operator cannot be 0. Okay, I know that you will ask this question. One is integer, one is float. What will happen? Maybe I suggest let us move to an explicit code to answer all these questions. So arithmetic.c. Okay, so this is the basic structure, and at the end you have exit 0. Okay, so instead of writing printf scanf, I will just use constant values. Okay, so let's say int m n, and let's say float f g, and maybe double x y. Okay, instead of int, of course, you can use long int, unsigned int, and all this stuff. But let's not worry too much about this. So first I say m equal to 5, n equal to 2. Then I just, okay, maybe I use another variable, m n o p, p maybe, f g h z. Here I say p equal to m by n, and I just print the value of p. And then if I, in the next expression, I calculate the remainder, then I print. Let us see what happens. Of course, now this will create some warning messages because I have introduced several variables, but I have not used. Anyway, I'm going to use it soon. Okay, so these are the warnings that you would not get without this -w all flag. Okay, so p is 2 as it should be, and p is 1, the remainder is 1. Okay. Now let us see what if I say f equal to m and g equal to n. Okay, so now apparently there is something illegal you have done. You have copied an integer variable to a floating point variable, and here also an integer variable to a floating point variable. But C actually allows this kind of type conversion. So these are examples of automatic type conversion. The compiler can clearly see that there is a type mismatch. This is float. Sorry, this is integer, whereas this is float. Okay. So the compiler knows that this number, whatever is represented by m, has to be converted to the integer format, to the floating point format. And the formats are actually different. Okay. So the compiler will automatically do. Of course, we will see later that you can yourself instruct the compiler to do it. Anyway, one by one. So now if I do the same thing here, just copy and then I will change the names. This is H. And this is F. And this is G. Okay, so as I mentioned, since F and G are floating point variables, F%G makes no sense. But this is the first time in my life I am applying this percent operator onto float variables. I do not know what the compiler will say. Let us see. Warning, form representation type int. Is the compilation successful? No, it is not successful. Oh, there is another problem. I should print as float. Okay, so you can see F%G is not allowed. It is an error. Invalid operands to binary percent, have float and float. Okay, so this is not allowed. Okay, so once I suppress this line.
Sir, I did not understand it. This means why the percent and percentage of was not allowed.
Percent is the Euclidean remainder operation. But if you take two floating point values, remainder does not make any sense, right? What is 2.5 remainder 3.3?
Yes, sir. Got it.
Okay, makes no sense.
Yes.
In this case, of course, the values are favorable, so you can still talk about a remainder. But in general, floating point values do not make sense under this remainder operation, modulus operation. Okay, so that's why I had an error. But when I removed that line, it is now perfectly printing 2.5. Now I will do one thing to illustrate m by n. Okay, so h is the target value, which is a floating point number, whereas on the right side, you have integer operands. Okay. So what will happen actually? Let us see to illustrate. Okay. So you are expecting 2.5 to go to h, but this does not happen. Why? The reason is this. Whatever value, whatever type h is, it is for the moment not relevant. Okay. I am first evaluating the right hand side, the R value. Okay. And when I am done with this evaluation, then I will try to assign that value to h, and at that point of time, if some typecasting is necessary, if automatic type conversion is necessary, I will do, not before that. So m is an integer variable, n is an integer variable, m/n is therefore treated as an integer division, not a floating point division, although the target value is a floating point value. Okay. So in the scope of this right hand side, there is nothing that specifies that I have to talk about a floating point division. Okay. Because the operators are both integers and you are applying this operator, this slash operator on the integer variables. So it has to be something like an integer division. So this will return 2, but when the compiler wants to save this to this variable h, it will convert 2 to the floating point format and give the value 2 to h. Okay. Now, one by one, Yes. Automatic conversion be possible if L value was of int type, R value of float. Yes. What do you think the compiler will do? It will simply truncate the fractional part and store that value in. Okay, so one by one, let me explain all these subtleties.
I'm asking if the float value is to be converted to int, won't the compiler raise an alarm like possible lossy conversion? Like,
No,
won't it do
automatic
like?
conversion does not raise any alarm. Automatic conversion does not raise any alarm. Then there is a why both H are different. That's why I am illustrating. In this H, F and G are floating point variables. And whenever this operator slash operates onto floating point variables, the compiler knows that you are making floating point division. So when you print H here, you will get 2.5, which is the result of floating point division. On the other hand, since M and N are integer variables, the compiler knows that you are applying this slash operation onto integer variables. Okay, so the result is whatever division is. So the result is 2, and then it is typecast to H and stored here. Okay. Okay, so now first let me answer one of your questions raised earlier. Yes, because the first one is the values. Yeah, that's what I am trying to illustrate. This M by N is an integer division because both the operators are integer variables. M and N are both int. And you are applying this slash operation on two integer variables. The result is not 2.5. It is 2 because here you are doing integer division. After this, you are assigning this to a floating point value. So that involves some kind of typecasting, which is done automatically by C. That is the reason we are facing this problem. Okay. Okay. I hope this is clear. Okay. So yeah, the next question. So what if I have something like this? M by G. So M is now integer, G is float. What will happen? Let us see. Then I will explain why this thing is happening. Now actually you can see the correct value, 2.5. Why? I will just explain. Maybe I will do another thing. Let us make this F and return that as M. Again, you will get the value 2.5. Okay. Why? Okay. The reason is that when an operation applies to let's say an operation is something like star, which is maybe addition, subtraction, multiplication, division, something like that. Operand 1, and you have the second operand, operand 2. But they are not of the same type. So there may be int, float, double. They are also int, float, double, but they are not same. Okay. Now what the C compiler implicitly does without your explicit warning or instruction, it will look at the precision of this with this. Okay. So C's convention is precision of an integer is less than the precision of float is less than precision of double. Okay. Now, when there is a mismatch of precision, okay, what the C compiler will do, whichever variable has the smaller precision, it will automatically convert it to the other format. So if it is integer by floating point. Then this is of higher precision, so I will be converted to float format. And then this will be followed by a floating point division. Okay. If you have something like a float by a double, okay, this is of 32-bit, not exactly 32-bit. This precision is higher, so these will be converted to double. And then this division is a double precision division, not a single precision division. Okay. So here also the same thing happened. There is a mismatch between the precision of M and G or of M and N. Okay. Therefore, M is first automatically converted to a floating point variable, floating point value, and then this is float, this is float. So this division is now a floating point division. Okay. Similarly here, F is floating point, this is integer. Okay. But this has higher precision, so the compiler will automatically convert this to a floating point value, and then it will make float by float. That is the reason you are getting correct things here. Okay.
Excuse me, sir.
Yeah.
Sir, but for this, do we have to change the other parts? Like in scan, we have ampersand, so it is different for int and float. So does the compiler make changes in that also by itself? Because here I is changing to float.
Are you asking why and is necessary? Ampersand is necessary. Is that your?
No, sir. Sir, I am asking ki, if there is int and if there is float, then we have to use different
Yes,
things.
yes,
Like,
yes. Compiler must know in which format you are specifying the input.
yes, sir. Sir,
Yes.
so will it convert it by itself because we have defined I, but it has converted it to float?
Look at this. So you are giving a value 5.2, let's say. Okay. If it is read as integer, it will store 5. It will ignore 0.2. On the other hand, if it is read as %f, it will store 5.2. Okay, the exact type is important. Okay. So, yeah. So if you say %d and supply a value 5.2, only 5 will go. And this 0.2 will be ignored. Okay. So exact typing is very necessary in C. Okay. It answers your question, right?
Sir, I'm not asking this. Sir, I'm asking ki here, like the computer has only turned int into float. Sir, in the precision example that you gave.
Yeah.
So, but will it not be wrong because if we have defined it by I, then we would have used ampersand d there. But now, if it is getting converted into float, so actually there should be ampersand f.
Oh, no, 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 no. Ampersand has a separate purpose. This is basically, please let us wait. Ampersand means actually you are passing the address. It has nothing to do with values. And C has something called parameter passing by value. Therefore, if you want some value to go to F, G or whatever, you should pass the address. We will come back to this maybe about a month later when we study functions.
I think he was
Okay, sir.
talking about the format specified, the percentage F and percentage D. That
No, no, what is the problem? I do not understand.
so maybe he was asking like if it is int, if he thinks it is int, then percentage D is to be written. But if the
Yes.
compiler automatically does it into float or something like that, then percentage F. So wouldn't there be an error or not? I think that might be his question.
Okay. So, okay. Again, the same question is coming. So, you are not passing D, you are passing and D, but anyway, so maybe if you say D, it's an integer, y %d, I can just say %. Okay. Yeah, that's true, but this is actually, maybe I would call a peculiarity of the C language. Or maybe I will think about it at some point of time. It may be necessary. Okay. Is it driven by necessity or just a syntax? This question is okay. Maybe I hope I understood your question. Okay. Okay, I will think about it and let you know. Yeah. Okay. Anyway, so I believe I am going a little bit slow, but anyway. So suppose for the moment that I want to make this division using m and n, and still I want the value 2.5. Okay. So this is what is called your forced typecasting. Okay. So now if you do not say anything, m is int, n is int, so m by n will be an integer division. But if you write something like this, then you are instructing the compiler to convert m to the floating point format. N will continue to remain integer, but then since this is float, this is of higher precision than n, therefore this will also be automatically converted to the floating point format, and now you will get the value 2.5. Okay. So this is the difference between automatic type conversion and forced type conversion. Okay. Of course, we do not call forced, we just call it typecasting. You explicitly say that I want this to be a floating point division, so you can so you convert one of the operators to m. Of course, you can also convert both of the operators to the floating point format. This is also allowed. Okay. So now I will illustrate the last thing. Okay. Let us say f is 3, g is 7, and I have used some floating point values. X is 3. Actually, 3 means 3.0. Y is 7. Okay. And then I say this is not an integer division because they are stored in the floating point format, f by g, and z equal to x by y. Okay, so let me just print this.
Excuse me, sir.
Yeah.
So what if we write that h equals to f%g?
We have seen, right? This is creating compiler error. I have already illustrated that, right?
Yes, sir.
Okay,
Yes.
technically I should write lf, although yesterday we have seen that %f also works. But anyway, let us be ANSI compliant and write lf. Okay, so h and z are this 428571. Okay. Now what I do, I am using something a little bit ahead of time. So this if condition 3 by 7, right? Okay, so I now comparing h with 3 by 7, but this time because I have used this constant 3 point and 7 point, so you can additionally add something 7.0 if you are not comfortable with just point without anything. This is also fine. The earlier thing was also fine. then what do you expect? Will it say equal or unequal?
Sir, unequal, sir.
Why?
Sir, I think because it only has taken some points, like up to some decimals.
So this is also 3 by 7. This is also 3 by 7. This is also 3 by 7.
I
So
think equal, sir.
the same approximation will hold always. Anyway, let us run. Unequal. Okay, so let me do another thing. Then let us see the difference. Z equal to this. So Z is also 3 by 7. H is 3 by 7. Z is 3 by 7. Now let us see what happens. Equal. Okay. So do you understand why this happens?
No, sir.
No. Okay. In C, whenever you say 3.0, 7.0, things like that, they are anyway constants. They are floating point constants, but they are not as such associated with any variable, right? These are constant values. In C, any floating point constant is of type double. Okay. So this is double. This is double. What C makes it say double by double, that is a double precision floating point division. Now it says that the value to be assigned is of type float. So it will convert that double precision value to a single precision value and store it there. Okay. Well, I would say it's not okay. Well, it actually happens here. Where? Actually, I made a mistake. So F is okay, fine. No, this is fine. So this is double. This is double. So this is double precision division. So the result is a double precision value. And if I look at H, this is float. This is float. So this is a single precision division. The result is also stored in a single precision division, single precision floating point variable. So this is a floating point thing. So this is a float. This side is a double. Okay. So whenever you have mismatch in the two types, this thing which has smaller precision will be converted to double. But here, this is the result of a single precision division. Okay. So some bits are already ignored. Okay. When you convert this to a double precision value, there is no way you can recover this ignored bits. Whereas here you are making double precision division. Okay. And therefore you are actually holding a larger number of bits. And there is no type conversion. So here in this division, many bits are already ignored. And when you convert it to double, so these ignored bits will essentially be replaced by zeros. Okay. But here you keep some other extra bits. Do not pad them with zeros. So when you compare them, they look like different. But if you make a double precision division, as in the case here Z, now we are comparing, this is double, this is also double. So double versus double you are comparing, and it's exactly the same value. That's why it's printing equal. Okay. So this typecasting, whether it is done automatically by the compiler or forcibly done by you, you should be careful. Okay, so these are some idiosyncrasies of the compiler. Now, what if I do, if I force this to be a floating point division by converting both 3.0 and 7.0 to float, now you will see equal. Right? Equal, equal. Okay. So without this, this will be unequal because these two formats are slightly different. Both are approximate formats, but double has larger precision. It's closer to the original value than float. Do you understand this?
Yes, sir.
Oh,
Sir, I have a doubt.
well,
Sir, double has more number of bits. Even after that, both percent f and percentage lf are printing till 6 decimal places.
no, that's what I mentioned. That's the default behavior. You can anyway convert it to anything you like. %.10 LF, %.10 F. That's the default behavior. 6 piece of
Okay.
that you can anyway change any point. This is the default behavior. Okay.
Okay, sir.
Okay, so that's it. What I will now do, I hope there are several examples to illustrate these points and typecasting and all that stuff. Then if I have something like ax plus y star z, now y is an operator which is common to both x and z. So which one will take precedence? So we know that this is to be interpreted like this. So you can use this parenthesis, okay, in order to disambiguate. So this is equal to this, but not equal to x plus y star z. Okay, so this is where the precedence of operators come into picture. Okay, so you must have heard about something like BODMAS or BEDMAS rules. Okay, the same rules apply here. So bracket has the highest precedence. Okay. Then, of course, something which is not captured by the BODMAS or BEDMAS rule is the unary minus. Okay, like minus x. And then you have division, multiplication. So you have division, multiplication, in fact, percent. They are all of the same precedence. Then you have addition and subtraction. Okay. Now, therefore, if I have something like this, so what does it mean when I say x slash y %z star z %w? Okay, how do I make sense out of it? Because they are all of the same precedence. Okay. So for operators in the same level, in this context, they are called left to right associative. And here also it is the same. So this means that I will do this first, then I will do this, then I will do this. And similarly, if I have ax minus y minus a plus b, this means I will first do this, then this, and then this. Okay. Okay. So this is again a normal, I would say, thing that you would expect to happen. I just want to mention another thing, maybe a few other operators. Okay, I talk about this tomorrow, not tomorrow, next week. But the arithmetic operations, apart from these typing problems, okay, typecasting or type matching problems, is not a real nuisance. And standard precedence and associativity rules hold when you deal with these arithmetic operations. Next, we will just give you an introduction to the logical operations. They apply mathematically to Boolean values. So Boolean comes after George Boole. So this is a two-valued thing. It can be either true or false. A Boolean variable is either true or false. Okay. C does not support any default Boolean data type. Okay. So no explicit Boolean data type in C. Okay. So you can use an integer, a character, a float, a double, even something like a pointer to denote a Boolean value. So the convention is this: whenever this integer or character or float or double, they evaluate to 0, it is treated as false. Whereas this integer, character, float, double, whatever it is, if it evaluates to anything other than 0, not necessarily 1, 2, 3, minus 1, minus 2, minus 3, 2.0, anything other than 0 will be treated as true. Fine. So this is how C handles Boolean values. You can use int, char, float, double, even pointer. So you do not know what pointers are for the moment. If that quantity evaluates to 0, then this is false. If it is true, if it evaluates to anything other than 0, then this evaluates to true. Okay. So if I say 5, okay. So what is its Boolean value, true or false?
True.
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 Okay. And what is the Boolean value of 5 minus 5?
False.
This
False.
is false because it evaluates to 0. Okay. So you can use these values, but you can also do something. These things, this is the last thing I will mention today, and I will stop. Okay. So logical connectives or operators. Okay, so these are this and or not. So these are three basic Boolean values. Okay. So when I say x equal to equal to y and z, so let us give some values. Int x equal to 5, y equal to 6, z equal to 7. So this will evaluate to what? X equal to y. So okay. So these operators we will see a little later. The comparison operators, maybe in the next class. So let us look at this logical connectives. This is x and y, are they equal? 5 and 6, they are not equal. So this will evaluate to false. Okay, which means this will evaluate to 0. What is z? Z is 7. This is 7 evaluates to true. But false and true, this will together evaluate to false. Okay. Whereas if I say something like this, x equal to y or z, then with these values, 5 equal to 6, they are not equal, so this is false, or this is true. So this will evaluate to true. So this illustrates this and or operators. So now I can also say something like this: if not.
Sir, your voice is cracked.
What? What? Oh, my voice is cracked. Is it still now?
No, sir, it
No,
was
sir.
fine, I think.
No, sir, it's okay.
No,
Yes,
it
it's fine.
your local
Yes,
problem.
sir.
So x equal to y, x and y are not equal. So this part will evaluate true, false. And if you say not of that, this entire thing will evaluate to true. Okay. So you can use these connectives, and if you want to compare, maybe I just give you a listing. So this and, or, and not are logical connectives. I just tell you the truth table. So the truth table of and, which is double and, never use single and. So this is the input 1, input 2, output. Both are true, true. Any one of this is false. This is false. If both are false, this is false. And this is the truth table for or. Double pipe, input 1, input 2, output. Let me write true, 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 false, false, true, false, false. This is true, this is true, this, any one of this is true, then this is true. If both are false, this is false. And for this not, the input output behavior is this. Not of true is false, not of false is true. Okay, so you keep this in mind. And maybe a little bit, it's just past, maybe I will just take 5 more minutes to introduce another set of logical operators. Okay, so once again you note that false always evaluates to 0. True can be any non-zero value. So what the compiler returns as a true value, you do not have any control. You do not always say that it has to return 1. False definitely means it will return 0. True may be returned true. True may be interpreted or returned as anything non-zero, not necessarily 1. Okay, and that may be compiler specific. Okay, so I'll just mention this table, then we will stop. Comparison operators. When you are given two numbers, real, integers, okay, these are the equality. If they are equal, true, if and only if x and y are equal or evaluate to equal values. Okay. In fact, this x and y need not be variables. There may be expressions. Okay. This is true if and only if x and y evaluate to. Of course, you can type this in Unicode, but not in C. So you use this not equal to. And then you have the standard x is less than y, x is greater than y. These are standard things, but you do not have this less than equal to and greater than equal to things, except unless you use Unicode. So you have x less than equal to y, x greater than equal to y. Okay, so let me give you a quick couple of examples. Is this true or false?
True, sir.
This is true, right?
True.
Because this side is 7, evaluates to 7. This side evaluates to -6. 7 and 6 are not equal. And so this is true. Because this is connected by not equal to. Then what about this?
False.
This is
False.
Why? This side evaluates to, this is an integer division because both the operators are
Integer.
integers. So this will evaluate to 2. And this side it will evaluate to 2.5.
Yes.
And once again, whenever the two sides are of different precision, this 2 will be converted to 2.0. And this side is anyway 2.5. 2.0 is not greater than 2.5. Sorry. This is mistake. I should not use this. Equal to. Yeah. So this is false. Okay. Also, maybe another example. Okay, so if I write something like this become problematic, right? Because you do not know which one, this one or this one will take precedence. Okay, so once again there is a problem of precedence. So 3 equal to this binds both to this and to this. So shall I bracket here or here? Okay, now as far as I remember, I should bracket here. And has higher precedence than this. Okay, but I want to show you one thing. If I do this kind of bracketing, oops. Okay, so I am giving this explicit bracket. There is not enough space, but assume that this parenthesis ends here. This evaluates to what?
True.
True, right? Because 3, this is false, but this is true. So true or false is true, and 5 is a non-zero value. True and true is true. So this is true. Okay. Yeah. So these are most of the things that I liked to cover. Only one thing, as far as I see, I am missing is something like some short circuit operators. Okay, maybe I will just, or if you want, I can just spend another 5 minutes to show you. Is this okay?
Yes, sir.
Okay. So
Yes, sir.
this is just another matter of syntax. There's nothing great about it. So suppose I am dealing with an operator op. So I have a variable where I am assigning where op expression. Okay. So op may be addition, subtraction, division, and all that stuff, but not the logical operators. Okay. So this in C can be abbreviated like this. Okay. So for example, recall that we have used this z equal to z minus 2 I have used. So I can, this has the same interpretation as this. Okay. But if I have something like z equal to 2 minus z, this is not same as. Okay. So similarly, so you have plus equal to, minus equal to, star equal to, percent equal to this. I don't know what kind of convenience that is. Okay, but these operators are sometimes useful. In the next class, I will just start with this. There is yet another thing, x plus equal to 1 and x minus equal to 1. So you are incrementing or decrementing by 1. So this has yet further shortcut. You can write x plus plus or as plus plus x. There is a subtle difference between these two. Or you can write this in decrement by x minus minus or minus minus x. Okay, so this is the increment operator. This is the decrement operator. This is called the post increment. This is called pre-increment. This is post decrement. This is pre-decrement. And there is a subtle difference between these two. We will see. Maybe in the next class, I will just illustrate this. Okay, so these are just some boring things about the syntax, but sometimes we find this syntax useful because you have to write little less. Decrement z by 2. Instead of writing compute z minus 2 and assign that to z, you just say decrement z by 2. And here you say increment x, decrement x, things like that. Okay. Anyway, so I think I am done today. So there is a question. Again, explain this. Which one? How is this implied with character data type? I see. Truth value, right? This question, Priyank. Yeah, the truth value. Okay. This thing actually I didn't mention. Very difficult to mention every detail. Okay. So you have character. And I talked about ASCII values. And I told that these are they are in the range minus 128 to 127, or if you think about this as unsigned character values, they are in the range 0 to 255. So this is char. This is unsigned char. Okay. So you see that characters are not actually characters. So when I write A, it's something like this or like this. But to the computer, it is nothing but 65. Okay. Also, 65 is not exactly 65. It is 1 to power 6, right? 5, 4, 3, 2, 1, 0. It is basically this bit string. And there may be some 1, 2, 3, 4, 5, 6, 7, another 0. Okay. So to the computer, a character does not look like this or this. It is just this bit string. Okay. So what happens if that bit string contains all 8 zeros? Okay. So something which has ASCII value 0. What kind of character is it?
So small a is 97 na?
Okay, sorry again. This is let's look at this as capital A. Capital A. Okay. To the computer, these shapes do not matter. This way they write it or this way you write it. It is up to your Windows or some graphics manager to render this value to this form or this form. Okay, so the question is, what is the character with ASCII value 0? In C, this is written as this, quote 0. This is called the null character. Actually, you will require this character when you study strings. Yeah, so this is called the null character. Okay, so this is a special character which you cannot see, and it is important to deal with this null character when we talk about null terminated strings. This will be used later. Yeah, and I didn't get this question. Again, explain this. This means what?
Now understood, sir.
Okay. This question is answered. Okay, fine. Okay, so only this null thing will evaluate to false. Everything else, A, B, C, D, ampersand, hash, even space will evaluate to true. Because space has ASCII value 32. Okay, and it's written as \0 within quotes. Yeah. So anything else?
Sir, why are you using null now?
Why are you using? Why are you using?
I mean, in character we are using some A and B and C like. But what is the use of null, sir? I mean /0. Where it is used?
That's what I mentioned. When we study, first of all, you see that it's an integer value. So 0 is a natural value. Okay. So there will be some character whose ASCII value is 0. And that is called the null character. This is the first thing. Okay. So 0 is a natural integer value in this range or this range. So some character will have ASCII value 0. And that I call this. Second question is, sir, what is the use of this?
Sir, the difference between a string and integer now.
No, a string is something different. We will see. We have not yet talked about
percentages.
Yeah, please wait. When we study when we learn about arrays, we will talk about strings. Okay. Please, I would say, hold your excitement. Okay. Maybe by the end of this month, we'll be able to study strings. And this null character is needed, as is already mentioned, for terminating strings. So it is not just this null character is not just which happens to be there, but it's used. Okay, so the use we will see. Yeah, tell if there are any specific things. So this, I think, yeah, short circuit operators. This is just a matter of syntax, and this is yet abbreviated like this, plus plus or plus, but there is subtle difference that requires a little bit of.
So I had a doubt regarding the implicit type conversion in C. So like if we have any data type, like whether int or anything on the to which we want to assign a value, and anything on the right hand side like double will automatically get converted without showing any error in C.
Yeah. Okay, so in fact, I forgot to mention one thing. Why did I write precision? So there is another thing which we have used. So precedence or precision of char is just 8. This is less than this. Actually, in between I have short int, then long int is somewhere there anyway. Okay. Yeah, so think of this whenever I say var equal to expression. This is evaluated first, irrespective of what is the type of var. At this moment, you just assume that var is not there. You are just evaluating this expression. Okay. Now, whatever your precision and precedence, associativity, all the rules hold, according to those rules, you evaluate this. And that evaluate value may be an integer, a float, a double, a character, or whatever. Okay. Now, when this is completely evaluated, and this evaluation of this expression is independent of whatever this data type is. Now, when you see that I have evaluated something and now I want to assign this value to this, then I will look at the data type for this. So I'm storing a value I have computed by evaluating this expression. And now I am storing, then and only then I will look at the data type for this variable. If necessary, I will convert that value computed to the format suitable for var. So that is the idea. In fact, in a C program, you may simply write expression, okay, without assigning anything. This is also allowed. But this is a useless expression, evaluation, because you are not storing it anywhere. Anyway, but this is also allowed. Okay, does it answer your question?
Yes, sir. Actually, in previous, like in lower classes, I had done Java, and there, if we tried to store, like if the expression returns something in double, and
Okay.
the variable was of int type, then it used to give an error. So, won't any such error be given in C?
No. Java gives error. I am very surprised to know this,
Yes,
but
yes,
maybe
sir, because it gives
possible.
possible
Because
loss
Java
of.
is actually a little bit more user friendly, so it may issue an warning. In C, automatic type conversion will be done. There will be no error. This is perfectly
Okay, sir.
legal in terms of the C syntax.
Okay, sir.
Okay. And of course, if you know something like what is that called, Python. Python, nothing is declared. So although types are there, but you can override types any point of time. So a variable is not associated with any type. In one line, it can be character. In next line, it can be an integer. Next line, it can be a float. Next line, it can be a string, and so on. Anyway, so we are studying C. So let us, for the moment, I would say, concentrate only on C syntax, and let us not compare with other languages. Okay, every language is good or bad in its own right.
Data over.
Yeah, so tell if you have any other doubts. Anyway, I think that you have to write some programs in your lab. Otherwise, all these theoretical concepts will mean nothing. I'm trying to give you several examples to illustrate possible problems that you may face. Okay, like this, unequal, equal, and things like this. Okay, which you may face during your assignments, programming assignments. Okay.
Sir, how to use
How to
boolean?
use?
Boolean. You haven't given an example.
That's available. You can use anything, int, char, double, float, anything you can use as boolean. Okay. And the convention is anything if that you are like here, you see. I'm using z as a boolean value. Okay, because it is inside this. Because it is currently assigned the value 7, it is evaluating to true. Okay. So instead of int, I could use float, double, even char, unsigned int, everything. The convention is 0 means false, non-zero means true. So there is no separate data type for boolean. Okay. Again, I believe in Java it is there, boolean. But in C, anything you can use. Integers, floats, characters, even pointers you can use. But anyway, we will study pointers later.
Sir, we should try the problems given at the end of the slides on the CSE website.
Yes, so you can try these things, write small codes, verify whether your understanding is correct or not.
Yes.
Okay, so these are all small codes, right? Of course, in your lab, you will look at more, I would say, elaborate codes. And those things will be evaluated. Now, these are not exactly for evaluation. This is for enhancing your understanding. If necessary, you write small codes and verify, as I am doing, writing small codes to illustrate concepts. Yeah. What else? Please tell the website. My goodness. Okay, I just write this. So we go to cse.iitkgp.ac.in. So it's HTTP, of course, /PDS. This is the course for all semesters, but if you want to look specifically at this current semester, you just write this /PDS/current. Okay, anyway, yeah, this is a more, I would say, explicit link, but using current, you can also do it. Yeah, this is also fine. Semester/2021S. Yeah, so any other question?
No, sir.
No, sir.
Okay, then let us call it a day.
Thank you, sir. Yes, sir. Thank you, sir.
Okay, thank you.
Thank you,
Again,
sir.
Thank you, sir.
see you again. See you again.
Thank you, sir.
Thank you, sir.
No.